Okay, so let's now discuss the four kinematics equation. Guys, this is very important. This is a lifesaver if you're like taking an exam, or if you're taking the national medical admissions test. This is your lifesaver in physics. The kinematics equation. So here we have the v is the final velocity, the equation number one. That's equal to initial velocity plus acceleration times time. So remember the notations that we use. V, final velocity, V naught, initial velocity, A, acceleration, and T is time. The second equation is displacement, which is mostly the final displacement part. That's equal to 1/2 times the quantity V naught plus V. V naught is initial velocity, V is final velocity, and T is time. The third equation is V squared, final velocity squared, equals initial velocity squared plus 2ax, acceleration and displacement. And the fourth equation, x equals v naught t plus 1/2 at squared. Now, how do you use these equations? You can always go back to the basic equations like this, but in problem solving, it is better to know the kinematics equation, because if there are given variables and there's the required variable, what is being asked, then it's easier to choose the appropriate equation from these four equations. So perhaps in solving problems involving kinematic variables, the first thing that you need to do is you have to draw and visualize the problem. So I would say draw and visualize. So physics is abstract. If you cannot see it, it's useless. But if you're going to apply it and you visual, this is the initial velocity, the car is moving like this and like that, the track, the MRT is moving, that's real. You have to visualize it. Okay, physics is real. It's not just math. Not it's too abstract. No, it's real. Of course, math is real as well. But what I'm thinking is, in physics, you have to see it more. Okay, more than the equation itself. We have to think of the application. Okay, number two, choose a coordinate system. Okay, so choose a coordinate. Choose a coordinates, and you usually start at x equal to 0. So even if it's, the Earth is an unlimited distance and whatever, so whatever is your starting position, choose that as your x naught equal to 0 to simplify the problem. And of course, you start your timer there. Timer t naught is equal to 0. So that's why sometimes we can just appoint x naught equal to 0 and t naught equal to 0 to make it simpler, right? Okay, and number three, write the given variables and the required. So write the given and required, what is missing, what is being asked, required variables. So here, what we did here, we write initial velocity, we write the time, we write the displacement, and what is required, the average velocity. And here we wrote v naught, v, t, and acceleration. So for example, what if given initial velocity given, acceleration given, t given, and then ang hinahanap, what is required is the final velocity. So you can choose from your equation. Yes, it has this one has initial velocity. Yes, correct. This is acceleration. This is time. Oh, and this is required. So what you're going to use is equation number one, right? So what if this? What if initial v naught is given, time is given, and let's say acceleration is given, but you're asked to find the displacement. What equation are you going to use? This one has v naught, but we don't need the final velocity. Okay, this one has time, but there's no acceleration, so we cannot use equation number two. Equation number three, there is v naught, there is x here required, but there's no time. What we have is time. So we cannot use equation number three. How about equation number four? There is v naught, there is time, there's acceleration, and the Of course, your displacement, what you're looking for. So you're going to use equation number. So here, equation number 4. Okay? So those are the tips. You really need to write your given and write your required variable. Okay? So let me erase this. We'll have a better notes. Okay. Step number 4 when solving problems. Choose the right equation. Actually, we just did it. So choose the correct equation. So we did that already. Once you identify your required variables and the given variables, you can now choose the right equation. So for our example, we choose equation number 1, and then later on we choose equation number 4. And then, of course, number 5, execute or solve. Okay, be careful with your units. So most of the time it's usually in SI units. Okay, so these are the kinematics equation. I will end this video because the next video is the derivation of the kinematics equation. Where did it came from? Did we just invent it? No, it came from the basic definition. So this is the next video is the derivation.